hydroxide. Okay, all examples of bases, right? Now, in an acid-base neutralization reaction, memorize this, you'll always get water, at least in this class, okay? In an acid-base neutralization reaction, you will always get water. H2O. You can remember that, right? Let's look at some examples actually now that we have this. What's going to happen here, basically, our hydrogen, I'll just put it here, an acid-base neutralization reaction, our hydrogen aqueous plus our hydride aqueous, whoops, what am I drawing that for? On an arrow. Are going to join together, and you're going to get H2O liquid like that, right? That's basically what's going to happen. A little bit more complicated, but I'll show you that. All right, let's get an example. We'll take hydrochloric acid, plus we'll take sodium hydroxide. And this is obviously acid-base neutralization reaction. Your acid, your base, okay? You have to check to make sure everything's gonna balance, right? There's one proton, there's one hydroxide, that's +1, that's -1, the charges gotta cancel. So it's 1 to 1, so you're good to go. Now what did I say? Acid-base neutralization reactions, what do you get? You get water. Just like that. Again, the H is going to join up with the OH, actually. And then here, what's going to happen? The sodium is going to join up with the chlorine, okay? So plus, minus, you get +1, -1, and we're going to get NaCl. You don't have to worry about it precipitating, you're fine, okay? It'll just be aqueous, right? Now in a reaction, we got our water, right? This is called the salt, whatever you get, not just sodium chloride. If you had lithium, it'd be a salt, okay? Whatever it may be. Let's take a look at another example. Here again, I have my sulfuric acid. Has 2 protons. Here I have potassium hydroxide. So again, we have to make sure that this balances, okay? There's 2 hydrogens, how many hydroxides do we need? We need 2, right? So put a big 2 in front of there. What do we get in the acid-base neutralization reaction? What did I say? Water. Right? Now, what's the problem here? Well, we have 2 OHs, we have 2 H's, so that's going to make 2 H2Os. 2. Okay, right? 2 OHs, 2 H's, one for one, so there's 2 of them. Plus we get what's left over, right? We have sulfate, right? What's the charge on sulfate? 2 minus. And if you didn't remember that, you can tell there, because hydrogen is +1, so sulfate's got to be 2 minus. What's the charge of potassium? It's alkali metal, it's +1. You should have that memorized. But there's 2 potassiums, right? That's the way you get that. And again, don't worry about precipitation or whatever, okay, just put aqueous. So this is our acid-base neutralization reaction for sulfuric acid. Again, the point here was that there was 2 hydrogens, thus we had to put a 2 in front. We still got water, and this is still called the salt. This is still be called the salt, okay, even though it's not NaCl, this is called the salt. All right, also, don't write any crazy crap for H2O. People write HOH, they write OHH, they write all kinds of crazy crap. That's not, none of that's correct, okay? It's H2O, right? Not any of these. let me see here. Da, 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 da. So, while I have this example up here, we can also write complete ionic and net ionic equations for these. It's very similar to what we just did. Write everything in its ionic form as it is in solution. All these are aqueous, so that's what we're going to do, right? So that's what we're going to do. We're write the complete ionic for this. So, this is going to come apart, right? It's aqueous. So it's not H2, these are ions, so it's 2H plus aqueous, plus SO4, 2 minus, aqueous, plus 2 potassium plus aqueous, plus 2 OH minus aqueous, goes to, now this formed H2O, it's not going to come apart. It's formed a molecule, right? So you just leave it. 2H2O liquid, and then this also comes apart, right? It's aqueous. Again, not K2, it's 2 potassium plus aqueous, plus sulfate, 2 minus aqueous, like that. This is the complete ionic. Now, net ionic, we're going to do the same thing again. What do we have in a precipitation reaction? We had a solid. What do we have here? We have a liquid. It formed a liquid. Okay, so it was a reaction. So just write that down. Go 2H2O liquid, and then write down the ions on the reactant side that were necessary to make that happen. Well, there we needed the hydrogens and we need the OHs. So I'm going to go 2H plus aqueous plus 2H minus aqueous, like that. And technically you can divide through by 2, but I don't care if you leave it this way, okay? So 2H plus 2OH equals H2O liquid. So again, remember, acid-base neutralization reactions, hydrogen joins up with OH to form water. Be careful if you have a diprotic 2 or more, and this is called diprotic acid, has 2 hydrogens, be careful, make sure everything's balanced. Your complete ionic equation is similar to a precipitation reaction. Again, write everything as it is in ionic form. Your net ionic reaction, you only have if you form a product. And the precipitation reaction was a solid, here it's a liquid, H2O, and you just write down the species that make that up, right? I hope I'm explaining that so it all makes sense. I'll continue right on, all right? We're gonna finish up this chapter. We're talking about oxidation reduction reactions. Oxidation reduction reactions, or redox reactions, are where electrons are transferred. Okay, electrons are transferred. Redox reactions for short. Okay? Oxidation reduction reactions. Basically, redox reactions involve the transfer of electrons. Okay? Rust is probably one of the most common types, all right, of a redox reaction. Tarnish with silver is also a redox reaction. Basically, electrons are being transferred in rust from iron, Fe, to the oxygen, okay? That's why your car was solid, right? The atom that gains electrons is reduced. Now you might be saying, why does something that gains something, why is it reduced? Think of its charge is reduced, okay? If I have chlorine, right? Chlorine has 17 protons, 17 electrons, it's neutral. If I transfer an electron to it, what happens? I have 18 electrons, 17 protons. What's the charge on it? -1, right? Negative. So it's reduced, okay? It's reduced, the charge is reduced. So the atom that gains electrons is reduced. The atom that loses electrons is oxidized. Okay? Let's take a look at an example. Actually, let me make some room here. We'll take a look at the formation of an ionic compound. The formation of most ionic compounds is going to be a redox reaction. We'll take a look at the formation of sodium chloride. So we're going to have 2 sodium solid plus a chlorine gas. So these are in their elemental form, okay? Things in their elemental form are neutral. So they have no charge, right? If these two are going to form an ionic compound, what has to happen? Sodium is +1, chlorine is -1. So each sodium atom, we'll just take a look at one individually. A sodium atom is going to lose an electron to a chlorine atom. The sodium will be +1, chlorine will be -1, and we're going to get NaCl, our ionic compound, right? But there's 2 of each, so we end up with 2 NaCl, like that. So each sodium, individual sodium, transferred electron to chlorine, forming 2 NaCl. Let me draw a picture. Here we're going to have sodium, has 11 protons, 11 electrons. Here we're going to have chlorine. Chlorine has 17 protons, 17 electrons, right? Both of them are neutral. Right? Doesn't matter that there's 2 of them stuck together. Doesn't matter that there's 2 there. Don't care. Now what's going to happen? Transfer 1 electron from sodium to chlorine. Now what happens? We have 10 electrons. We have 11 protons, right? That didn't change. What's the charge in this? More protons than electrons? We have Na+. What happened over here? We transferred 1 electron, right? Now we have 18 electrons, 17 protons. What's the charge in this? -1. You now have a cation and anion. What happens? The positive charge attracts the negative charge, forms an ionic compound. Na, the sodium, is oxidized. Chlorine is reduced. Chlorine gained electrons, right? So it's reduced. All right? Let me just quick write some examples of redox reactions. I already mentioned rust, formation of rust. Let me write a couple more. If you bleach your hair, when Chpt bleached his hair, he was doing a redox reaction. Formation of rust, bleaching your hair, combustion reactions when you burn something, whether in a campfire or butane lighter, or if you're in a chemistry lab with a propane torch or a Bunsen burner. And formation of ionic compounds. Okay? Those are all examples. And I want you to be able to identify, oh, also, I forgot an important one right here. Sorry, production of electricity in batteries. Your battery is a redox reaction is what's going on. Yeah, and well, I'm not going to get more into it than that. But it's basically a chemical reaction where electrons are being transferred. When electrons are transferred, they're used to create an electric current that powers your cell phone, your smartphone, the camera right there, whatever it may be, okay? Or in your car, start up your car. Your battery, you have a redox reaction, to create electrical current to start your car. Once your car is running, technically you should be able to unhook your battery, because then your car runs off the alternator, which produces electricity. But anyway, combustion reactions. Let's see here. Identifying redox reactions. This actually isn't that difficult, okay? At least not in this class. Basically, identifying redox reactions. Basically, a substance reacts with elemental oxygen, simply meaning O2, that's its elemental form. A metal reacts with a non-metal, forming an ionic compound. A metal reacts with a non-metal. Sorry about that. Let me rewrite that. And combustion reactions, when you burn a carbon-hydrogen compound in the presence of oxygen. Let's take a look at an example. Let's take a look at an example here. Sorry, page 227. Which of these are redox reactions? I'm going to say, identify any redox reactions. Okay, so take a look at this. A, two magnesium solid plus O2 gas goes to 2 magnesium oxide solid. Well, what was